so that there is some amount of continuity, right? So resolve f into horizontal and vertical components. In that case, what will be this fy along the y direction or the vertical component? That will be f cos theta, here this one, right? And along this direction, what do you have? Along this direction, this horizontal direction, that will be f sine theta. Now if I have to resolve fh into rectangular components, now this fh, it can also have rectangular components along this x direction as well as along this z direction, right? Now this fh, it is contained in this xz plane, isn't it? It is contained in this xz plane, correct? So now what will be the components, rectangular components of fh? Rectangular components of fh, now this angle was phi, isn't it? See here, this is phi, so this angle was also phi, so this is your cos component, okay, and this is your sine component. Am I correct?
Yes, sir.
Yes, sir.
Right.
Yes,
So
sir.
here you have fh cos phi as the x component of force, right? Now what is fh? From here you just replace it, that is nothing but f sine theta y. So f sine theta y cos phi. Again, what will be the value of fy?
Sir, it will be
Right.
fz.
F
Sir,
Yeah.
right. It is
Y
FZ.
sin phi.
Yes, yes, yes. So that will be fh sine phi, right? This one. This one. Okay. Now this will be fh sine phi, right? Now this, what is fh sine phi?
Sir, excuse me.
Sorry, what is this one? fh f sine theta y. So here again you have f sine theta y sine phi. So in terms of this force F, you have found out the again the components of FH, rectangular components, right? So this is how you can find out different forces in different orientations, and you can solve different types of problems.
Excuse me, sir.
Yes.
Sir, in the third figure, why you consider xz? You we can consider xy also, yz also.
You have to find out the rectangular component of FH.
Yes, sir.
What do we mean by rectangular component? Say I have a force like this. Okay. And say it is contained in the XY plane. This force is contained in the XY plane. Right. And you have to find out its components, rectangular components. Do you find it, the rectangular component along the Z direction?
No, sir.
So, that is given in the question. You have to find out the rectangular components.
Yes, sir. Okay, sir.
See, okay. Now for this FH, this is my X direction, and say along this Z direction, they have written it as Y direction, right? So this will just be FZ. Okay, so along this Z direction and along this X direction, it will have its rectangular component, isn't it?
Yes.
Right. Now with angles between F and the axis, okay, say for you have theta X, F makes an angle theta Y, and F makes an angle theta Z with the X, Y, and Z axis, right? So now this is related to just a moment. I will just show you this part, this thing. Just go to the syllabus once. 3 dimensions. Okay, equilibrium in 2 dimension and 3 dimension. This is related to this one also. Correct? So now coming back to our slide. Yeah. Now rectangular components in space, right? Now with angle between F and the axis, if we know that theta x, theta y and theta z, right? Now along this fx, okay, along this fx, if the angle is theta x, okay, then what will be fx equal to f cos theta? Similarly, fy will be f cos theta y and fz will be f cos theta z. If the force F makes angle theta x, theta y and theta z with x, y and z axis respectively, right? So obviously f cos theta x, f cos theta y and f cos theta z will be the components along the x direction, y direction and my z direction. Correct? Now, how will I write it in vectorical form now then? So the force vector, that will be fx I cap plus fy j cap plus fz k cap in terms of the unit vectors, right? So along x direction I cap is the unit vector, along y direction j cap is the unit vector and along z direction k cap is the unit vector. So here if I just substitute f into cos theta x I plus cos theta y j plus cos theta z k, right? F is common here. This fx, fy and fz value you are substituting here like this. Okay. So f is common and cos theta x, cos theta y, cos theta z, you just the summation of that. Now this can be written as f into lambda, right? Now what is this lambda? We are replacing this portion by lambda, right? Now in vectors we can say that this is the direction cosine. Okay, here already I have written it. Already I have written that. Okay, so lambda is a unit vector along the line of action of F, and cos theta x, cos theta y and cos theta z are direction cosines of F. Okay, so this one, cos theta x, cos theta y and cos theta z, they are the direction cosines of the force F that you have, this one, right?
Yes.
Now direction of the force is defined by location of 2 points, right? Now this I have already discussed with you in some of the previous classes, right? Suppose in space, this is my x, y and z axis. Suppose in space 2 points are given to you, point M and point N, right? Point M has coordinates x, y, 1, 1, x, y and z 1, and point N has x, y and z 2. Okay. Now vector joining M to N, what will be that? X2 minus X1, I cap, Y2 minus Y1, J cap, and Z2 minus Z1, K cap. Right? So basically that has been denoted by dx, dy, and dz. Dx equal to X2 minus X1, dy equal to Y2 minus Y1, dz equal to Z2 minus Z1. Right? And they have substituted that. Okay. So now here, F is equal to F lambda, we have seen in the previous case. Here, what will be the value of lambda? Now here again, F is the magnitude and lambda is a unit vector. Unit vector along direction of F. Along direction of F, right? So what will be basically lambda? So magnitude of this D vector, okay, we are just dividing it by this one, right? We have discussed it in the last class. So from M to N, I find
sir.
out a vector, I find out a unit vector, and I just multiply the magnitude with that, right? So it is just written in a little bit sophisticated manner. That's the same thing, right? So what will be fx now? F into dx by d. Fy will be f into dy by d. D means magnitude of this vector d. Magnitude, this d is magnitude of the vector d, which joins m and n. Okay. So Fy will be f into dy by d, and Fz will be obviously the magnitude of force into dz divided by magnitude of vector d, right? So I don't think this is very much tough. Now let us come to a problem. So here it is given to us the tension in the guy wire is 2500 Newton. This one. This is your guy wire, right? What you have to do is find out components Fx, Fy and Fz of the force acting on the bolt at A, here. Okay, so here you have the tension. So you have to find out component Fx, Fy, Fz of the force acting on the bolt at A. And you also have to find out the angles theta x, theta y, theta z, defining the direction of the force. Right? Now, how can we solve this problem? This height is given to you as 80 meter. This is 40 meter. And this distance is given to you as from here to here. This midpoint of this to midpoint of this, that is given to you as 30 meter. So can I consider this point as the origin? Can I consider it? So say along
Yes,
this
sir.
direction you have the x direction. Say along
Yes,
this
sir.
direction you have the y direction. And along this direction, say you have the z direction. Say if you have it along this direction, right? You can also take it in this direction. That doesn't matter, right? So x, y, and z, right? Now, how can I find out the force now? Say for simplicity, I consider this side as positive z, this side as positive z, and this side as negative z. Can I find out the coordinates of A? I can easily find it out. Can I do it or not? A will be
Yes, sir.
equal to
30.
Yes, sir.
40,
Comma
Sir,
0, comma
comma,
point
along the y direction it will be
0,
40, 0,
0,
0,
30.
comma 30.
30.
30.
Sir, we are
So what
writing
will be
z, y, x.
this side I have taken z, no? This side I have taken z. Y will be 0.
Sir, x, y.
Y will be 0. Okay. This and this point is at same level. Point O and point A. Okay. So A will be 40, 0, 30. Now what will be point B? Along the x direction it will be 0.
0, 80, 0.
Right? So now I have this one. So based on the relative location of point A and B, determine the unit vector pointing from A towards B. Pointing from A towards B. Because tension is acting in that direction. Right? So I have to just subtract this one. So if I just write AB, vector A to B, then that will be minus 40I plus 80J minus 30K. Right? Now, AB cap will be what? 1 by mod of AB minus 40I plus 80J minus 30K cap. Okay. Now the tension is given to me as 2500 Newton. Right? So what will be the tension vector then? So the tension vector will be equal to 2500 into AB cap, correct? So now apply the unit vector to determine the components of force acting on A. Now noting that the components of unit vector are direction cosines for the vector, you can now calculate the angles. So here this you have in the form F is equal to mod F into lambda, or say unit vector. So here you have the unit vector, right? So whatever you have along with the I cap, J cap and K cap, so cos theta x will be equal to that. Cos theta y will be equal to whatever you have with the J cap, and cos theta z will be equal to whatever that you have with the K cap in the unit vector, right? From that you can easily find out by taking cos inverse. You can easily find out theta x, you can easily find out theta y, and you can easily find out theta z. Can I do it?
Yes, sir.
Yes, sir.
Yes. Great. So now what we can do is we can easily find out the angles theta x, theta y, theta z, defining direction of the force. Right. So what they have just done the same thing that I have told you. AB. Okay. They have found out the vector. They have just taken the opposite. Positive z direction, they have taken it in this direction, right? It will depend upon me. The answer will depend upon me, whichever axis that I choose, right? You just have to write down which direction is you are considering as your positive x, your positive y, and your positive z, right? So they have just found out AB, then magnitude of AB, they have found it out, right? The unit vector lambda, they have found it out. So determining the components of the force 2500 into the unit vector, they have just multiplied it to get the force vector or the tension vector. Now coming to scalar product of two vectors, right? Basically the scalar product of two vectors is the, whatever that you have learned is the dot product. Okay, that is your dot product. Now the scalar product or dot product between two vectors P and Q, it is defined as P dot Q, that is equal to PQ cos theta, right? We all know that. Now scalar products, they are commutative, that is P dot Q equal to Q dot P, distributive and associative. They are not associative. Okay, they are not associative. So they follow the commutative and distributive law of vectors. Now scalar products with Cartesian unit components, so P dot Q, say if you have Pxi, Pyj plus Pzk, into this one if you just do that, then P dot Q will be equal to Px into Qx, Py into Qy plus Pz into Qz. And we also know that I dot I, obviously it will be 1, cos 0 is 1, right? J dot j equal to 1, k dot k equal to 1, and ij, jk or ki, that value is equal to 0. Now similarly for P dot P, you have Px square plus Py square plus Pz square. Okay. Now, scalar product of two vectors, let us see the application of these. Let us see how we can, what is the application of the scalar dot product. Now, angle, the first application that you have, it is your angle between two vectors, right? You can find out the angle between two vectors. So we know that P dot Q equal to PQ cos theta, right? Again, P dot Q will be equal to PX py, qy, and pz, qz, just the summation of that. So px, qx plus py, qy plus pz, qz divided by pq, that will give you the angle between the vectors. The projection of a vector on a given axis, right? Now, if I say q dot p, q is a vector, p is a vector. Now, if I say q dot p, then this means projection of q on p. Can I say this? Can I say that q dot p means projection of q on p? Anyone?
Yes.
No, sir.
Yes, sir.
No, sir.
No, sir.
Dot
Then
p cap होगा.
what is it? Can you tell me?
Sir, Q dot P cap we can say.
Divide by P.
Uh-huh.
Q dot p.
Q dot p. Can I say that to be projection of q on p?
So magnitude
sir.
of projection of q on p.
It is same as P dot Q. Sir, Q dot P upon mod P.
Q dot p by?
Mod of P.
Okay. Right. So now coming to that. So projection of a vector on a given axis. POL equal here. This one, that will be equal to P cos theta along this OL direction. Along the, say this is Q. Between P and Q, you have angle theta, and you just drop a perpendicular, right? So P cos theta will be this portion. This portion is nothing but P cos theta. So projection of P on OL is P cos theta. Now we know
Yes,
that
sir.
P dot Q is equal to PQ cos theta, right? So P
Yes,
dot
sir.
Q by Q, P dot Q divided by the magnitude of Q, that will be equal to P cos theta or POL, or projection of P along OL, right? So whatever that you are saying about the projection of Q and P, that was correct, right? So P dot Q by mod Q, sorry, P dot Q divided by mod Q, that will be the projection of P onto Q. Similarly, if I wish to find out projection of Q on P, then here this will be replaced by mod of P,
P.
and here it will be replaced.
Q
Here it
cos
will
theta.
be,
Q
yes,
cos
it
theta.
will be, this will be Q cos theta and this will be P. Right. Now for an axis defined by a unit vector, then P dot lambda, what will you get? Px cos theta x, Py cos theta y, and Pz cos theta z. Okay? Here, this one. Say along this direction you have a unit vector lambda. So you just find out the dot product. So that will give you Px cos theta x, Py cos theta y, and Pz cos theta z. Now coming to vector product of two vectors. Now can you just recall what was one more, what significance with respect to force you have in case of dot product or scalar product?
So
Where in forces you had to find out dot product? What is force dot displacement?
work.
Work.
Work
So
done.
that is dot
Work
product.
done.
Yes,
So
sir.
that was
Work
your
done.
dot product again.
Yes.
Right. Now vector product of two vectors, right? That is nothing but again your cross product, right? So the concept of a moment of a force about a point, that is easily understood. by using vector product of two vectors or cross product, right? This is particularly important for your moment about a point, right? While discussing moments, we are going to discuss moment of a force about a point. We are going to discuss about Varignon's theorem. And we are going to discuss about one more thing, which is your moment about an axis. Okay, moment about an axis. We are going to see that concept also. So the cross product is clearly understood through applications, like in case of moment of a force and cross product. For that, it is very both are interrelated. How we are going to see that? Now, vector product of two vectors P and Q, it is defined as vector V, which satisfies following condition. Now, what are these conditions? Now, line of action of V is perpendicular to plane containing P and Q. Okay, so say you have two vectors P and Q, and vector V gives the cross product of P and Q, right? So vector V, that is equal to P cross Q, right? Now this vector V, the line of action of this vector V is perpendicular to the plane which contains these two vectors P and Q. Okay, now magnitude of V, it is given as PQ sine theta. In dot product you had PQ cos theta, so magnitude of V is PQ sine theta, and direction of V is obtained from right hand thumb rule, this one, from the right hand thumb rule. So here you have P. Say if I wish to find out P cross Q, say this is my plane which contains P and Q, right? So if I wish to find out P cross Q, right, then the line of action of P cross Q will be perpendicular to this plane, this one, right? And how will I determine if it is along this direction or this direction? By the right hand thumb rule. What I'll just do is I will curl my fingers from P towards Q. I will just curl my fingers from P towards Q, and in that case what will happen? My thumb will point upwards from P to Q, right? Now if I find out Q cross P, then my curl of my fingers will point from Q towards P, and obviously in that case my thumb will point in the downward direction, right? So this is how we find out the direction of the vector V, equal to P cross Q. Now in case of vector products, they are not commutative, but they are distributive, and they are also not associative. Again, like we had seen that I dot I equal to 1, J dot J equal to 1. Similarly here, I cross I will be equal to 0. J cross I will obviously be equal to K minus K, sorry. K cross I will be equal to J, like that. So this is again something very simple, which is already known to you. Now vector product in terms of rectangular coordinates, right? So Pxi plus Pyj plus Pzk cross. So this is my vector P, this is my vector Q. If I wish to find this out now, right, that will be found out very easily through the determinant. You just have to say, if you are trying to find out P cross Q, then you have at the top you will be having the unit vectors along x, y, z direction, I, j, k, the px, py and pz values, and qx, qy and qz value. say if you wish to find out Q cross P, then you have to just interchange these two rows. IJK will be the same. So at the top you will be having QX, QY and QZ, and at the bottom you will be having PX, PY and PZ. Now coming to moment of a force about a point, right? And how the cross product is applicable for that one. Let us just see that. Just a moment. Right. Now let us just see moment of a force about a point, right? Now say you have a body like this, okay? And in that body you have this point O, and some force is acting at point A. This force, it is acting at point A, right? This is point O about which I wish to find out the moment. So moment of F about point O. I wish to find that out, right? Now, point of application of F is point A, right? Now from O to A, I will join that using a vector, and I will denote that as a vector R. Okay. Now moment of F about O, it is now defined as moment about O is equal to R cross F. Okay, R cross F. Now the moment vector MO is perpendicular to plane containing O and force F. Right? So this is the plane containing R and F. Right? So the moment vector that will be perpendicular to the plane containing R and F. Now this is pointing in upwards direction. Why? Because if we are finding, right, yes, so R cross F. So what will be the direction now? You have to find that out from the right hand curl rule. Okay, so the moment vector MO is perpendicular to plane containing O and the force F. Magnitude of MO measures the tendency of the force to cause rotation of body about an axis along MO, right? So magnitude of MO measures the tendency. This line is very, very important, right? Because this concept will be also required for moment about an axis. Okay, so magnitude of MO or moment about O, it measures the tendency of the force to cause rotation of body about an axis along moment vector, along the axis, about an axis along moment vector, right? So basically MO is equal to RF sine theta, okay, which is nothing but F into D. D is the perpendicular distance of this force from point O, this part. D is the perpendicular distance of F from this part. We already know moment is equal to, moment about a point is equal to force into perpendicular distance, right? So basically this cross product, it denotes force into perpendicular distance. So R into F into sine theta, which is nothing but F into D. Okay. Right. Now the sense of the moment may be determined by the right hand rule. Any problem up to this? This is easy, right?
Yes, sir.
Right.
Not any
So,
problem.
yeah. So, not at all very tough for you. So, any force F dash that has the same magnitude and direction as F is equivalent if it also has the same line of action and therefore produces the same moment. Now, this same example I gave you in the first class, equivalent vectors. With respect to
Yes,
what? With respect to moment that is being caused by the force, right? So any force F dash that has the same magnitude and direction as F is equivalent if it also has the same line of action and therefore produces same moment. Okay.
Yes, sir.
Now coming to two-dimensional structures. So moment of force about a point like this, right? So two-dimensional structures have length and breadth, but negligible depth and are subject to forces contained in the plane of the structure. Okay. Right? So we are just considering a lamina, say a lamina. It does not have some thickness, only two dimensions. So the plane of the structure contains the point O. Here, this is the point O and the force F. So this is the force F that is acting on the plane. So MO, the moment of force about O is perpendicular to the plane, perpendicular to this plane, perpendicular to this plane, right? Now, if force tends to rotate the structure clockwise, the sense of moment vector is out of the plane of the structure and magnitude is positive. Okay. So if force tends to rotate the structure clockwise, the sense of moment vector is out of the plane and magnitude of moment is positive. And if the force tends to rotate the structure counterclockwise, the sense of moment vector is into the plane of the structure, which means inside. It is going inside, I mean like this, into the plane of the structure, and magnitude of moment in that case is negative. Okay, I think there is a mistake. This will be anti-clockwise. This one will be positive and this will be clockwise. Isn't it? So if this is clockwise and if I point my curl in this direction, then my thumb will go downwards. So in that case, moment will be negative. Isn't it?
Yes, sir.
Yes, sir.
In that case, the sense of the moment vector will be into the plane of the structure. Into the plane of the structure. And in this case, if I curl my finger in this direction, then my moment vector will point outward of the plane. And in that case, moment is positive, right? So this will be basically counterclockwise and this will be basically clockwise. Okay, so just a small mistake. Just a small mistake. So just ignore that, right? So this is how you take the sense of moment. I think there has been some repetition in the slide. So I'll just skip this portion. Now coming to moment of a force about a given axis. Okay. So when you had something like this, right? Say a force F is acting like this. Say this is your point O, right? So this is
As I make it sound, it's a
R,
very competitive field to
this
be a
is
successful
F.
douche tuber on this website. It's really an ass
Okay.
ass world when it comes to this shit.
Now-
So you have to really go all in to try and find something.
Say
unique
this
to
is
make
my
yourself stand
direction
out
of
in the
moment
douche
vector.
tuber community.
Okay,
And this guy really came.
this
up with
is my
something wild
direction
here.
of
This is
moment
a
vector,
used
which is
condom that he called
perpendicular
his
to this
mom.
plane.
Truly
R
nothing is
cross
sacred
F. We have
anymore.
found
the
out
gloves
the
are coming
moment.
off, and is the
Now,
condom clearly.
in the
Let's
very
check this shit
definition
out.
of
Let's see
the
how the prank
moment,
went.
we said a very important line. I marked it as VVI. Magnitude of MO measures the tendency
This
of
is
the
Kelvin.
force
He's his own favorite
to
comedian,
cause
constantly
rotation
making
of
himself
body.
laugh uncontrollably, and I have absolutely
Tendency
nothing
of
against this
force
guy at
to
all.
cause
I just
rotation
find him
of
to be the
body
perfect
about an
example for the
axis along
impact
MO.
douche tuber.
Okay, rotation of body along axis of MO. Right? So here if we come back, now this force will cause this body to rotate about an axis along this moment vector M. Am I correct or wrong?
Correct, sir.
Yeah.
Sir.
The force F will result in tendency of rotation of the body about an axis along M, right? This is what it is written. Now say if I wish to find out moment about any other axis, say this is one axis like this. This is one axis. Say this is L. Say this point is O, right? Now the tendency of the body is to rotate about OM. If I wish to find out moment about the axis OL, moment about axis OL, then what will I do? What will I do?
We have to put force
Anyone?
perpendicular to that.
Now if I find out
Sir, we
R
will
cross
find out
F,
component of
yes, yes,
along
yes.
OL.
Sir,
Sir, we will
projection of
component of force about OL Can you repeat the question? along OL.
My question is, this is my moment vector M, or moment about an axis OM. Okay, moment about an axis OM, or moment about only this point O. Now if I have any arbitrary axis OL which is inclined at an angle say theta with respect to M, how can I find out moment of this force about axis L, which is also passing through this point O? How can I do that?
So we will find the component of OL.
Yes, but before that we have to find out a unit vector along OL.
Yes, sir.
And then we have to find the component. Correct?
Yes,
Just
sir.
the dot product,
Yes, sir.
isn't it?
Yes, sir.
Yes, sir.
So projection of moment vector MO onto this axis. The projection concept we have learned just a couple of minutes back. So scalar moment MOL about an axis OL is projection of moment vector MO onto the axis. So along this OL, if I have a unit vector, okay, along this OL, if I find out a unit vector lambda, so we just need to find the dot product. So lambda dot R cross F. That will just remember this thing. Just keep in mind this thing. Moment about an axis. If you just remember this, you can easily solve the numerical. So lambda dot R cross F. You find that out and you will get the moment about an axis OL. Is it clear?
Sir, can you
Yes, sir.
give some
Yes, sir.
example?
Yes.
Sir, is
Yes,
the
I will give
examples
you
for-
example when I will be doing numerical. No, I will give you example. Okay.
Okay.
Okay. So with this we have completed a big portion on moments, right? So we are again going to continue on Monday. Okay.
Okay.
Thank you,
Right?
sir.
Okay.
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 Thank
So
you, sir.
Sister
Thank you,
Pratali,
sir.
Share the slides.
yes, I'll just do it. I'll just share the PDF. Okay.
Thank you, sir.
Along with
Execute.
whatever I have written.
Thank you,
Right?
sir. Thank you, sir.
Excuse
Sir,
me,
कल
sir.
वाला भी कर दीजिएगा वो नहीं मिला।
Thank you, sir.
Yes.
Sir,
सर इसके previous class वाला भी